In this video, we are going to go over how to graph and statistically analyze your data when your independent variable is discontinuous. You can see here, my independent variable is the type of bread. It is gluten-free or with gluten. That is not something that is numerical, and so I'm going to use a different type of graph. I'm going to highlight the words here and the averages, and I'm going to say insert, and this time I'm going to put in what I call a bar graph and what Excel calls a 2D column. You can see here that the titles, gluten-free and with gluten, are on my x-axis because I highlighted them. If you're having trouble with that, make sure that you highlight it. I will add my chart title, of course, which I'm just going to take from here because I'm cheating. And then I can go over here and say add chart element. I'm going to add a title above the chart, and it is going to be the average glucose concentration as a function of bread type. And then, of course, I'd want to label my y-axis. So that's the vertical, and I will highlight that and delete, and I will call that glucose in milligrams plus or minus to the nearest 0.1 milligram. So here's my graph, and the one thing missing are my error bars. So I will again go to add chart element, error bars, more error bar options. I'm going to custom specify the value, and of course I will put in my standard deviation. There they are. Now if I'm looking at this and I'm trying to determine, is there a statistical significant difference between the glucose concentration of gluten-free and with gluten bread? It's hard to tell here. It looks like my error bars may overlap a little, and so I want to know if there is a statistically significant difference. So in this case, because I am using discontinuous and a bar graph, and because I have two different independent variables, I am going to run a t-test. There's two ways to do that. You can use the stat pack that we downloaded earlier, which is right here, or you can take a shortcut, which I'm just going to show you on this page. So I will say equals t-test, and Excel says, would you like a t-test? And I say yes. It says, what would you like to take a t-test of? Array 1 versus array 2, so I need to highlight array 1. Now remember, in a t-test, we're taking into account standard deviation and all kinds of other variables, so we need to have every individual trial in there. And then array 2. And then it says, is this a one-tailed or a two-tailed t-test? This is a two-tailed. Most of the t-tests that you run will be two-tailed. In order for it to be two-tailed, it means, do you want to know if there's a significant difference if gluten-free is higher than gluten, and or if gluten is higher than gluten-free? So we can go in either direction. And yes, I don't care which one's higher, and so I'm going to put 2. And then do we think that both have the same chances of appearing? And are they not paired? They are not paired. They are two separate things, so we're going to do 2. So 2, 2, that's going to be the most common when you run your t-test. Then I'm going to press enter, and I'm going to get a number. This number is 0.03. This is my p-value. If you remember, we want our p-value to be less than 0.05. So p is equal is less than 0.05. So therefore, I can state that there is a statistical significant difference in the amount of glucose between the gluten-free and the bread with gluten. So I can say that the gluten-free bread has more glucose than the bread with gluten. Now let's go on to sheet 2. Here, I did the same experiment, but I made it so that my data was a little closer together. So I'm going to, again, highlight the titles and the means and insert a column graph. Again, this looks like there's a large difference between the two, but look, they changed the axis scale. So I'm going to add a chart element, error bars, more error bar options. And I'm going to customize my error bars and specify their value. And here I will specify and press enter. Now they look a little bit less, right? So just adding those error bars allowed me to kind of make my axis go back to normal, start at 0, and it kind of allows me to see, there's a little bit more overlap than I would have thought. Of course, you would add your chart title and you would label this axis, but I'm going to now show you how to do a t-test using the stat pack that we downloaded last week. So I'm going to go up to data analysis. I'm going to find t-test. This is going to be a t-test, assuming equal variances, okay? So it is not paired. These two, gluten-free and gluten, are not paired with each other. So we're going to do a two-sided t-test, and we're going to assume that there are equal variances. So I'm going to press OK, and then it's asking me, what is your variable for range 1? I'm going to highlight the title, gluten-free, and all the trials for gluten-free. And then for range 2, I'm going to highlight with gluten and all of the trials for with gluten. And then I'm going to say, yes, I did have labels, so that it kind of knows that I had labels. And then I'm going to say, I want it outputted right here. Okay? Let me say okay. I'm not sure what happened there. Now, here it gives me a lot of data. It gives me, widen this one and this one. Okay, sorry. It gives me the mean, and if you look up here, the means match 3.9, 3.58. It gives me the degrees of freedom. It is my number of trials, -2, total number of trials -2. It gives me my P, if it was a two-tailed or if it was a one-tailed. Again, we're going to have a two-tailed t-test. And my p-value is 0.26. What does that mean? 2.7. It means that my p-value is greater than 0.05, or the probability that these results occurred by chance or that there is no statistical significant difference between the two is 27%. And that is too high. We want a 5%. We want 0.05. So in this example, I would go on and I would say there is no statistical significant difference in the amount of glucose in gluten-free versus with gluten bread, according to my 5 trials that I did. I hope this helps. Thank you very much.